Hello everyone, welcome to this channel. This question is from Olympiad Pathfinder, Chapter 2, Multiple Choice Question number 40. A particle is moving with constant angular velocity on a circular path of radius r in the xy plane. Okay. If observed from a reference frame moving with constant velocity along the z-axis, the particle will appear moving on a helical path of constant pitch small h. Making use of the given information, what expression can be deduced for radius of curvature of the helical path? Four options are given. We have to select the correct options. Let us solve this question. X, Y, and Z is a fixed frame, and the particle P presently at A is rotating with angular velocity omega p in xy plane. But the observer who is seeing the particle is moving along the negative of the z axis with a velocity vz. So it appears to him that this particle is moving in a helical path with a constant pitch h. So we can show the velocity of the particle at A with respect to the observer as omega p into r is the tangential velocity of the particle on the circle along the negative of the x-axis, and vz is the velocity of the particle relative to the observer. So we will apply the equation like velocity of particle with respect to observer will be velocity of particle with respect to the fixed frame xyz minus velocity of observer with respect to frame xyz this we are knowing that it is omega p into r minus I is the unit vector in this direction because x is in this direction and this is opposite to the x-axis, means towards the negative of the x-axis. Velocity of observer is in the negative direction of the z-axis, so we have taken just minus k. So velocity of particle with respect to observer will become this. If we take the magnitude modulus of the velocity of particle with respect to observer, we will get equation 1 like this: omega p into r whole square plus vz whole square, the whole thing in the bracket square root. Now the things to be noticed: by the time particle will complete one revolution, the observer will see the particle travel a distance of h along the z-axis. Instead of here, observer will see it over here because The gap from the observer for the particle is increasing. Observer is moving down. So we have assumed capital T with the time in which the particle complete one revolution. So in this capital T time, the observer will see that it has risen to, the particle has risen to a height of h. So we can write that Vz into T is equal to h. So Vz will be h by T and 1 by T will be Vz by h. This is equation 2. We know that the angular frequency, that is of the particle omega p, will be equal to 2 pi by capital T, the time period. So 1 by T we will replace by Vz by h. So we will get equation 3. Let Rc be the radius of curvature of the helical path. So we can write angular velocity of particle with respect to observer into Rc is equal to velocity of particle with respect to observer. So Rc will be Vpo divided by omega p. This is equation 4. Since the time period observed by the observer will be same as time is not dependent on the frame of reference, hence omega p naught will be omega p. So Rc will be Vp naught by omega p. We will put the value of omega p from equation 1. Vpo from equation 1. So it will be like this. And further omega p we will be putting from equation 3. So finally we will be getting Rc is equal to in bracket R square plus H square by 4 pi square whole thing under root. This is matching with our option A. So option A is correct. I will request, please subscribe the channel so that I can give more such questions next and release on YouTube. And hopefully you understood the concept behind it. Any doubt, please do write in the comment box. I will explain your doubt. I will clarify your doubt. Thank you.